getting there. Okay, I'm 1 minute late. Whoops, 80. Sorry, I was messaging a Year 7 student about the work today. Well, really? Cake emoji already? With 3 people. Must be a bit early this morning. Surely someone's listened to this music before as well. I hope so. I'd love it if you could tell me what it is without looking at the tab. Alright, well, I've got a lot of highs. I've got more people commenting than viewers. That's a bit strange. I must have bored people already. Sorry. Average watch time, 6 seconds. Yeah?
I like it.
Okay, I'm basically just going to keep going from where I left off. And where I left off was this bearings question. So I'm going to go from 16 to, it's like 20 something, and it's a maximum, one of those maximum problems. Our favourite. But yeah, just when I'm going through this, just keep in mind that this was the HSC last year, so you can get a bit of an idea of, I guess, the level of questions and stuff. Heavy metal, yeah, pretty heavy. Okay, classic question. I thought I'd save this for the beginning because it's quite a big one. Sketching this. I guess there's a couple of things we can take from this. And the first one is it's a cubic, so that means it's going to turn twice. So maybe you look at the highest power and you take one off and you say how many times it's going to turn twice. So there's a couple of things, I guess, before you even start drawing it, you can kind of think about what it might look like. And if your curve doesn't end up looking like that, then you probably made a mistake. 5 beeps. It's also negative, so a cubic normally looks like this. A negative cubic's going to go backwards, so it'll probably look like this, is what I'm going to estimate. If you've got every term, like an x cubed, an x squared, and an x, you can expect it's definitely going to actually turn at both things. If it's only got this and this or something, it might end up looking like it'll turn and then this will be like a, what do you call, a point of inflection, something like that. Just things to be aware of. But it says don't determine the x-intercept, so don't waste your time trying to factorize this. You can't factorize this because that's an extension thing. Anyway, okay, to sketch it, I probably need my stationary points. So derivative, vector x, minus 3x squared plus 6x, that's it. Set that equal to 0, factorize the 3x out, the minus 3x out, and x plus 6. That tells me x equals 0, and x equals minus 6. Maybe I'll draw a graph down. A bit mean that they didn't give us something to work with, but whatever.
Human music.
Okay, what have we got?
I like it.
X is 0. Oh, I need the actual points, don't I? Wish I've gotten that right. I've already made a mistake. Good start. Can't factorize. Get to minus 2. X equals 2. Okay. Minus 1. And for 2. So I'm just chucking 0 and 2 into here. Minus 2 cubed plus 3. 2.
I like it.
Minus 1. So minus 8 plus 12 minus 1. 4 minus 1, 3. That was lucky. 5 viewers still? Sick. Make sure my points are right. Yep. Okay, so 0 minus 1. Whoops. 0 minus 1. Let's call that. No. 0, 1, let's call that there. And 2, 3, 2, 3, let's call that there. Okay, I said before that it was going to look like this, so how can I fit that to my curve? Probably going to be like that, but I can test the concavity of each of these. So I'll find the second derivative. That's minus 6x plus 6. Okay. It has a point of inflection, so set this equal to 0. 6x equals 6, x equals 1. So that means that x is just f of 1 minus 3 plus, no, that's the derivative, minus 1 cubed plus 3 times 1 minus 1. 3 minus 2 is 1. Okay, so at 1, 1. So at 1, 1, around about here. That's going to be the point of inflection, so it'll change concavity.
I like it.
Remove that. Okay. The second derivative, so I'm going to test my stationary points, these two, my second derivative. That. It's going to be, so this is my second derivative here. Minus 6 times 0, 6 is 6, so that's greater than 0, so that means it's greater than 0, it looks like that, so it's a minimum. 2 minus 6 times 2 plus 6 is minus 12 plus 6 minus 6, that's less than 0, so that's a maximum. So that means this is a maximum, that's a minimum, and it changes concavity at this point. So my graph kind of looks like this. 4 marks. Right, I am freezing. Not the best graph, I guess I could have spread it out a little bit, but everything's there. Okay, find the integral of this thing. So I guess what you need to realize is when you're looking at fraction, you can either try and rewrite this to the power of something, or kind of like move that there. But when you're looking at a fraction, you're generally looking for a log. And I don't have my reference sheet at all. But it's basically so remember that the derivative of the log is the derivative over the original. So if you see a function and its derivative on top, then you're good. Now the derivative of this thing would just be 2x, so I kind of want a 2 to be there. So what I'm going to do is I'm going to go 2.5. So I'm going to make the top look like the derivative of this and not actually change the question. So that's equal to 1/2 2x 4 plus x squared. That tells me that I'm in this form, which is equal to log f of x. So that's on your reference sheet. So it's going to be 1/2 log or ln 4 plus x squared. Generally, when you find an integral, you'll just draw square brackets because this can't be negative. But in this case, there's nothing, no x value I can put in there that's going to cause this thing to be negative. So it's completely fine that I write it like in brackets, but you shouldn't lose marks anyway. I almost switched to plus c, so then it would have killed me. Yeah, is that right? Okay, now these questions are kind of common where they say differentiate this and hence find this. So pretty much what we're going to be looking for is if we differentiate this, it's probably going to look kind of like this maybe. We'll see. Now, you could expand this, but then you'd have to use the product rule twice. Ooh, actually not twice because that's just one. So I'm just going to call this u, that v u dash plus uv. So the u is obviously the only way I can write that. V derivative of u. Oh, there's a 2e to the 2x. U derivative of v. That's just 2. Okay, so let's simplify that. What do I do here? 4 e to the, now I've got 2 of these. can't do that yet. Alright, I'm going to factorize this, which is going to be 2e to the 2x outside of 2x plus 1 plus 1. So this times this is that, and then this and this is that. Okay, am I happy with that? Oh, I can keep going. 2e to the 2x, 2x plus 2, and then I'll take a 2 out, so that's 4e to the 2x, x plus 1. Okay, that's what I want, because now this looks like this, except I don't have this 4 there. So now let's just find the integral of this. Now, if you just had this question, you wouldn't actually be able to answer it, because like this isn't, like, how do you integrate that? I don't know. But I can use my last result. So if I fix this so it looks like this, so the only thing that's missing is the 4. So I'm going to put a 4 there and then divide by it. So if the stream is not the best quality, it's probably because I'm downloading Flight Simulator and it's 100 gig and I started it like the second I woke up. Okay, and now I know what the integral of this is. It's this, what I started with. So that's just equal to 1/4 times e to the 2x, 2x plus 1. Done. And you can see that that's only 1 mark. So really all you're doing is reading off your solution from the last question. But a pretty common question, because people will just forget this hence exists and then they'll try and start integrating this. But when it says hence, generally look up is what it's implying. Yeah. Oh, our favorite questions, the proof one. I remember I put this one in your exam and I had already done it. Good times. If you get really stuck on these, like they're not worth that many marks, like 2 marks. If you get really stuck, sometimes it's okay to just go, okay, I'm going to start with the left-hand side and I'll write left-hand side equals and I'll start working on it. And then you obviously want it to look like this side. So what you can do, I guess, at the same time is just start working on the right-hand side and try and hope that you end up with the same thing. And that's a perfectly fine proof. But I'm going to start with the left-hand side. So the left-hand side is sec theta minus cos theta. Whenever you see a tan, it's probably going to be the case that you're going to be looking for a sine on cos. The fact that I've got a secant here, let's transform it into something that I do know. And I do know, like try and get rid of the secs and the cosecs and the cotangents and bring them into reality. So this is 1 on cos minus cos. Now I've got 1 term here, I've got 2 terms here, so let's join these. So I'm going to cross multiply, or I forgot my theta. So I've got I'm going to rewrite the second one. 1 on cos theta. I'm going to times the top and the bottom by cos theta, so cos squared theta, cos theta. So all I did was go over cos, and then I squared this. Now I can go 1 minus cos squared on cos theta. Okay. When you end up with like 1 plus or 1 minus, just remember this one. So sine squared plus cos squared is 1. That's on your reference sheet as well. And then you can rearrange, so like move him over there and I end up with this. So basically this whole thing is sine squared. So I can write equals sine squared on, is really nice one, on cos theta. Okay, so that's like sine theta, cos theta. And like I said before, you're looking out for this sort of thing to make tan. So that thing there is tan. So I'm going to write equals sine theta, tan theta, and I'm done. You can just row a box. Okay, Kenzo, what a weird name. Driving his car, look, I don't really care. Trapezoidal rule, okay. So, nice of them to put in a table, nice of them to evaluate it, nice of them to not confuse me by giving me a function that I don't care about. I just need to use the trapezoidal rule. So the trapezoidal rule looks like, on the reference sheet, area approximately, what is it, b minus a on 2n outside of, it's like is it f of 0 plus f of a, f of b, and then plus 2 times all the other ones. So for us, that's a, that's f of a, that's b, that's f of b, so they're like a bounds. N is how many gaps I've got, so 1, 2, 3, 4, I've got 5. So it's going to be b minus a is that minus that, which is just 5 on 60. 2 times n, so 2 times 5. It's given us the function values, so 60 and 67. So 60 and 67, and then 2 times the rest of the functions, which is this, 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 and this. So 55 plus 65 plus 68 plus 70. I chuck all that into the calculator, and I get off the very top of my head 5.4. Now, it is kind of a word problem, so just consider what it is. It's, what's it asked for? Approximate distance in kilometers. So approximately 5.4 kilometers, and that would be fine. So 2 marks. That didn't really, that should have taken 3 minutes. It took about, well, I guess I would have had to type that in the calculator. Extra space. Okay, that's the first booklet. So we're up to the second booklet, which is 58 marks, remember? So just keep in mind that a second booklet may or may not exist. Alright. I feel like we did one of these questions, and there's a lot going on and there's not that many words, so just be careful. I've got a hot tea. Now this minus here tells me that the tea is cooling. So that's basically what's happening. It's degrees Celsius up to t minutes. So in other words, I can plug in a value for t in minutes and it'll tell me the temperature of the tea. It is telling me that, what does 25 mean? Curious. Okay, the temperature of, oh, that's interesting. Okay, this 25 basically means if I were to take the limit of this, so if I put infinity into there, this whole thing would be 0. And so then it's kind of like the limiting value of the temperature of the tea is 25, which is basically like that's the room temperature. It's going to move towards 25. 25 is where the asymptote's going to be. So if you graph this, it would look like this, and that would be 25. Well, actually, my graph would suggest that it never gets to 25, but it gets significantly close that it wouldn't really matter. That was a tangent. What is the temperature of the tea after 4 minutes? Well, if this models the temperature of the tea, then really all I need to substitute that for that. So I'll just write tea at 4 minutes, so you've got a 25. There's only 1 mark, so I wouldn't even need to show any of this working. 1.5 times 4. I chuck all that into the calculator, and I would get approximately 61.6. Okay. It says hot tea. It didn't actually tell us what it started with, so I'm curious what happens when you put a 0 into there. Now, if you put a 0 into there, this would all be 1. Okay, so it's 95 degrees started with, so it's not even boiling. At what rate is the tea cooling? Now, the second it says rate, that means differentiate. So I'm going to write d, now it's not dy, it's the derivative of the temperature with respect to time. So it's a little bit confusing because they use little t and big T, but the derivative of the temperature with respect to time, little t. So we're going to differentiate this thing. It's a little frustrating because I'm trying to differentiate that. So obviously that disappears because that's a constant. Now when you've got this, it's kind of the same as having a to the power of a function. When I differentiate that, it's L and ln A times the derivative. So times the derivative, and then you leave the rest of it. So also there's a 70 out here, so let's leave the 70. It's ln A is the 1.5, so ln 1.5 times by the derivative of the top. The derivative of the top is negative 0.4. Okay, and then I times it by the original thing, which was 1.5 have that. Holy moly. Okay, that's huge and looks really disgusting. Let me make sure that's right. Yeah. Yeah, okay. just be careful when you write this too, because you might imply to the reader that that's what you're looking for, but that's not true. Now, I want the rate after 4 minutes, so that means, I guess I could write it like this, the derivative after 4 minutes. Is it a function? Yeah. So I'm just going to substitute, let me write this whole thing.
Human music.
1.5. So again, you'd have to type all this into the calculator, which is frustrating. So times by 4. And that's going to be approximately equal to negative 5.934. Now, what does that mean? You might think negative is a little bit suspicious, but what it's saying is it's the rate at which the tea is cooling. So it's going down 5.9 degrees every minute. So that's the rate. Yeah, I guess. That's all I need, isn't it? Yep. Okay, last one. How long after the tea is poured will it take for the temperature to reach 55 degrees? So it's asking for, it's told me that that's T, the temperature. So I'm looking at this first equation again. So T, let me just write it. 70, that's my memory. Is that right? Yep. Now, if T is 55, that means I'm going to substitute 55 into here. This would give you your first mark. This is 3 marks. I think this is pretty generous, considering it's not that much. It's just rearranging an equation. Now, all I need to do is rearrange it for T. Now, it sucks because there's so many things in the way. There's this, then this, and then this. So I've got a lot to move. Let's move the 25 first. So 30 equals 70, 1.5, 0.4 T. I'll divide, so 3 on 7 equals 1.5 to the power of bracket 0.4 T. Now I'm going to get this thing off the power, so I'll take the log of both sides. Ln 37 equals ln 1.50. Okay. Oh, I messed that up. That bracket's there. So I took the log of both sides, which takes everything. Okay, so now I can move this because it's a power out the front. So ln 3 on 7 equals negative 0.4 T ln 1.5. Okay, I want the T by itself, so I'm going to divide by that and that. So T is equal to,
Human music.
so I'm dividing by that and that. Okay, so we got there. You probably get all the marks for this, but then I'll chuck it into the calculator. I get around about 5.22. What that is minutes. So it's basically saying that after 5.2 minutes, the T will be about 55 degrees, whereas it started at 95 degrees. So that's kind of cool. And it's been 23 minutes into my stream, which means my coffee is definitely negative 3 degrees. So that's nice. Shall we test that?
I like it.
Yum. Right. This looks like a daunting question. Like, this looks kind of scary, but it's really not. It kind of tells you exactly what to do, which is kind of cool. And the marks are allocated really fairly. I had a look at where they give you the marks, and I feel like it's pretty generous too. So you're given that this is a decagon, so it's got 10 sides. It tells you the perimeter. So in total, around there is 80. It says by considering this triangle. So it's actually told you what to do. So what I'm going to do is I'm going to draw that triangle, which is the one that they give you kind of. Why can't I never draw a good triangle? That connects. There we go. What does it want? It wants the area of the whole thing. Is that right? Yeah, okay. So it wants the area of the whole thing. So what I'm going to do instead is find the area of this. So I'll call this A1. And then just times by 10. So that should be kind of easy. It's also told us that it's isosceles. It's told us the perimeter is 80. So that means, so that's A, B, O. If the perimeter is 80, that means all of these add up to 80. That means AB, which is one of the sides, should be 80 divided by 10. So there's 10 of them. I just want to know what one of them is. If they're all 80, then one of them must be 8. So that tells me that that's 8. So that's kind of nice. Another thing I can do is I can work out, there's a lot to think about, I guess, but I just basically want to try and fill in this triangle. So I can't really tell what these two are, purely based on the fact that they don't give me anything other than the perimeter. But I can find this angle here. I can't find these. I don't know if I can, but I know that I can find this because if I were to just rotate this around the whole circle, that would be 360 degrees. And since there's 10 of these little parts, that means angle AOB, so AOB is equal to 360 divided by 10. So that tells me that that little angle's 36 in there.
I like it.
Work this out. Okay. Now, at the end of the day, I want to find the area. So it's a non-right angle triangle. So the area is, I think this is on your reference sheet as well, but I always remember it's half AB sine C. So that's how you find the area of a non-right angle triangle if you don't know like the perpendicular height, because I don't know anything about this triangle. So that's a half. The only angle that I know is this one. So I'm going to call that C. We'll call this C. So it's going to be sine 36. Now I need A and B. So if that's capital, if that's little c, then I need these two. I kind of can't find those two unless perhaps I have these angles. But now that I have this angle, I can find these angles. Because if this thing's isosceles and has to add up to 180, that tells me, so I'm going to move all this. You see how there's a lot of working out for a 4-mark question, or a lot of things to think about. So angle OAB is equal to angle OBA. So I've just said that that is equal to that because of isosceles, which is equal to, the whole thing has to add up to 180. So equal to 180 minus 36, that'll give me the total. And then I halve it. That's going to equal 72. So that tells me that this is 72 and this is 72. And I just verify that by adding these three and making sure they're equal to 180. So there was a lot involved in that. Okay, now that I have that, so 72, 70, what am I doing? 72. Now I need to find these. So what I can use, I only need to find one of them because it's isosceles. So I could just find this and say that that's the same. So really, this AB here is just something squared because it's the same thing. Now, what I need to do is, I've got a couple of choices. I could use the sine or the cosine rule, it doesn't really matter. I'll use the, so let's do this in another color. Let's call that X, that's what I'm trying to find. Let's use the sine rule. So the sine rule relies on the fact that I've got opposites. I've got that opposite and that opposite. So I'll go X on sine 72 is equal to 8 on sine 36. That means X is equal to 8 sine 72 on sine 36, which is approximately equal to, and I'd have to chuck that into my calculator, 12.944 ... Now, because I haven't rounded, I want to find the area, and I haven't rounded anything in this calculation yet. So I'd probably keep that in my calculator as A and S. And I'll chuck that in there. And then I get, that's approximately equal to 452.4 centimeters squared. Holy moly, okay. I have to think about all the things that are in this. Like, this relies on the fact that you need to recognize that isosceles, this has 10 sides. This is a circle, 360 degrees. We have to use the sine rule, we have to use a proof involving isosceles, and then we have to use the area of triangle rule for non-right angle triangles. So, pretty full-on question. Anyway, but it's not that scary. How many more have we got? 3 questions left. What am I up to? 30 minutes. I should only get another 10 minutes. Alright, continuous random variable. Probability density function, find K. These should seem really simple. It's told me that's just sine X, so they can be really mean and give you something gross, but sine X is pretty nice. I'm just going to quickly draw it so I can show you what you're looking for. Sine x looks like this, yeah? You want the area underneath the curve, because it's a probability function, you're probably not going to be looking at negative stuff, which means I'll probably be looking at nothing beyond there. It starts at 0, so here, and I want to find the value of k, so the value of k such that this area is equal to 1. So basically what I'm going to do is I'm going to integrate sine, find the area under the curve between 0 and something, and that should equal 1. So that's the play. So I'm going to integrate sine x from 0 to k, and that should equal 1. So when I integrate, I get negative cos from 0 to k, that needs to equal 1. So that's negative cos k minus cos 0, that's got to equal 1. So negative cos k plus, now cos of 0 is 1 equals 1. Okay, so that means negative cos k equals 0. That means cos k equals 0. And that means k equals, so when is cos 0? Cos looks like this, so I'm looking for that value there. You can just literally go like this, and you'll get that it's 90 or pi on 2. But if you know what the graph looks like, then you'll know that that's 90 or pi on 2. It hasn't told us. Bit ambiguous because it hasn't told us whether it's in radians or not. I'd probably give both answers here because it hasn't told us what to put our answer in. Provides, yeah, they left it as pi on 2, but I don't think, yeah.
Music.
I don't know. I'd leave both just in case. Okay, find p of x less than 1. That's basically just saying what's that saying? That's basically just saying like evaluate it between 0 and 1. That's basically what that's saying. So that's easy. That is basically easier than the last question. That's interesting. Is it because, what is pi on 2?
I like it.
Pi on 2. Oh, okay. In case you're wondering, pi on 2 is, okay, that it has to be in radians, because if this was 90, then that would be 90, which means that would be something massive, and that area would not be 1. That's why that's why, okay, so it's not this. I don't know how else to justify that, but I've just figured out that this is around about 1.57. So now it's asking for, so you can imagine that it looks like this, that's 1.5-ish. That's 1, so the area of this is going to be around about 1. Now it's asking for p of less than 1, so basically here. So I'm looking for the integral from 0 to 1 of sine x. Okay, that's why it's that. Or that. That equals negative cos from 0 to 1, which is negative cos 1 plus cos 0. What's cos of 1? What is cos of 1? Negative 0.99 ... plus cos of 0, 1. Negative 1.9998. Or how many? Oh, 4 decimal places. 9998. Is that right?
Human music.
Oh, it's plus 1. Idiot. Add 1. God damn it. Oh, let's just type this whole thing. Screw it. Minus cos. Cos. Oh my god, I have my calculator in degrees, that's why. Radians. Minus cos 1. Negative 0.54.
I like it.
0.4597. Okay, yeah, that's a bit of a warning. Just be a little bit careful. I was obviously working in that, and then I've tried to type something in degrees. That's basically saying cos of 1 degree, which would have been like there, which is why the function value would have been 0.99. That's what I had. So that was a little bit stupid. Okay, but 2 marks. One would be for this, surely. The other would be for this, I guess. I don't know. No, huh? Yeah, oh, actually one's for this. Looking at the solution, that's the first mark. That's pretty generous. Okay, 2 more questions. It tells me this is a circle. It doesn't need to do that. It could just say graph this and reflect it. So tell me it's a circle and then reflect it. So this question wants me to make a mistake. Whenever you see something like this, the equation of a circle looks like x minus a squared plus y minus b squared equals r squared. And remember, that's the center and that's the radius. So in other words, I need to complete the square on this. Okay, x squared minus 6x. So the way I remember it is I halve this and then square it. So I halve that minus 3, square it, plus 9. Y squared plus 4y. So I halve this, 2 square root 4 plus 4. Now I've got to move this minus 3 over there. So that equals 3. And because I've added these, I need to also add them. Now, if you factorize that, it ends up being what you halved. So like that's minus 3. So I can just write that as minus 3 squared. That's why I like doing it like that. So I halved that. So that was 2 squared equals whatever all this is. I can't add numbers. 16. Okay. So the center. So say sketch out does. Center at 3 minus 2, and the radius is like square root of 16, which is 4. Now I've got to reflect it. So that means the center, so imagine my center is currently at 3 minus 2, so there. It's reflected in the x-axis, it goes here. So the new center is going to be still 3, but positive 2. So new center at 3, positive 2. The radius will still be 4. So now just quickly, it wants a sketch. You don't have to be accurate at all. Actually, kind of. So 3, 2, 3, 2. Now, if the radius is 4, it's going to overlap here. It's going to overlap here as well. So, holy moly, that's terrible. Let's call it that. Just tidy it up. Showing the coordinates of the center and the radius. Okay, so I have to show the radius and the coordinates. So just show as much as you can. Okay, last question. A maximum question. They're always the funnest, but think about this. They always give you the answer, and you should be able to use it in the next part. If it says find the minimum perimeter, that means here's your function, find its minimum, differentiate it. But let's set it up. This is 3 marks. Generally, what these questions give you is an area and a perimeter, and it's up to you to come up with equations for both and then compare them. So let's have a look at this one. It's told me all this junk. Then it says it's got an area of 36. So that's area is 36. Oh my god, I just realized I forgot to times this by 10. I got to times that by 10. Which is 4, 9.
I like it.
Oh. That goes there. That I have to times by 10. And it equals that. Whoops, daisy. Alright, so basically all of this equals 36. So let's come up with an equation. So the area is going to be, now for this it's x times y, so xy. For this, it's going to be, because it's a quarter of a circle, it'll be quarter pi r squared.
I like it.
Okay. Do we know the radius by any chance? Yes, we do. That and that are the same, which means it's the same as that. So that's x, and that's also x. So that means this is x. Okay. I know that the area is 36. So I know, told that that's 36. Now, because we've used x and y, for it to make, I guess, logical sense in, I guess, your head, rearrange this for y like any function. So I'll move, what am I going to have to move? I'm going to have to move everything. I don't get y by itself. I'm going to move that and then divide by x. Yeah. So 1/4 pi x squared plus 36 equals xy. That means y equals 1/4 pi x squared on x plus 36 on x. Okay, so I've just split it up, but I've divided that by x and that by x. That's going to cancel, so I can simplify this. 1/4 pi x plus 36 on x. And you can see that I'm kind of already getting towards this, because I've got something on that and this thing. Now that's my area. I need the perimeter. So what does it tell me about the perimeter? Let the perimeter of the garden be P. Is that literally it? Wow, that's heaps generous. Okay. Well, it's going to be y plus x plus y plus x plus whatever that is. So let's just go P equals, so what have I got? I've got 2 y's, 2 x's, so 2y plus 2x plus, now I need a quarter circumference. So it's a quarter times 2, that's a half. Quarter times 2 pi r, which is x. Holy moly, there's a lot involved in this. Can I simplify? Yep. 2y plus 2x plus, what happens here? That's 2/4, so that's a half. Plus a half by x, that's p. That's kind of as far as I can go with that, it seems of it. So what I can do now is, okay, see how this only has x's in it? And my one has x's and y's in it? What I can do is, my y is a function up here that only has x's in it. So as soon as I substitute that, there's just going to be heaps of x's, which is probably not a good thing, but we'll see. So 2 outside of, I'll use square brackets. I'm going to chuck all of that here. So 1/4 pi x plus, if I've made a mistake here, then God help me. I'm going to do this in silence, I think. That's a half. Okay. Oh, I've almost got it. I have it all. What happens to this? Uh-oh, perimeter. What happens to the pi x? Why is it a minus? Oh my god, I'm an idiot.
Music.
That's a minus, which means that is a minus. I can't solve a one-step equation. That's a minus, which means that's, it doesn't, that means that is a minus, which means that's a minus, which means that goes and that goes, yay, which means 2x plus 72 on x. It wasn't too bad to find my mistake because I knew I had everything I wanted, I just needed these to cancel, so one of them needed to be a negative, so I just kind of went back and went, well, there's be a negative somewhere, but obviously I just solved that incorrectly. Okay, 3 marks, and that's a work for that. Now when it says find the smallest possible perimeter and show why it's a minimum, You're basically saying, here's my function, p equals 2x plus 72 on x. Show me that that's a minimum. The only way I can do that is to find stationary points and prove it's a minimum. So in other words, I'm just going to differentiate this. So I'm going to differentiate p with respect to x. When I do that, I get 2 plus, now let me just rewrite this as, I hate them written like this. So it's like 72 times 1 on x, if that makes sense. So the derivative of that is 72 ln x. So the derivative of that is log. Is that right? Am I going to start this up? Seems... Oh, I missed a square, have I? No? What's going on here? Oh my god, that's an integral. I'm so stupid. That's x to the minus 1, which means oh my god, how do you differentiate? 72 times, okay, so I've dropped this to minus 1, and then I take 1 off this, so minus 2. Okay, 2 plus minus 70, let's write it like this, 72 on x squared. Okay. Now, set this equal to 0, so that's 2 equals 72 on x squared, 2x squared equals 72, x squared equals 36, x equals plus or minus 6. Okay, I say that this has to equal 6 because x is a length on this, and if that was minus 6, that wouldn't make any sense. So, length. Okay, I found a stationary point at 6. Now I've got to determine its nature. So I do that by, what do I do? Put that in the second derivative. dp d2p dt squared equals, okay, what am I doing? It's this thing. The 2 goes, let me rewrite this. I hate when they're fractions, it confuses the hell out of me. 72 on x squared is equal to 72 times x to the minus 2. Okay. There's also a minus there, minus. So I drop that, so then it becomes 146 x to the minus 3. 146 on x cubed. Now at x equals 6. I've got 146 on 6 cubed. I don't need to evaluate that, I just know that's bigger than 0. Therefore, my curve looks like that. That means it's a minimum, and I believe I'm done with it. Oh, I'll find the smallest perimeter. Okay, so the smallest perimeter occurs when x equals 6. So in other words, for the smallest perimeter of this, that value has to be 6. So what is the smallest perimeter? Well, I have a function of perimeter and it's this thing. So p equals 2x plus 72 on x. That means p equals 2 times 6 plus 72 on 6. That's 12 plus 12, which is 24. Oh, what we got there? Max min problems, eh? But think about that. That was like 3 marks and 4 marks. That's 7 marks out of 100. So 7%. Just on one problem, one min-max problem. And that's it. That should have taken an hour. It took me 50 minutes. So 10 minutes down our sleeve, and we had 15 minutes. No. How long did it take me to do last one? 20 minutes. So that's now half an hour we've saved by obviously being very, very fast. But yeah.
I like it.
Yeah. All right. Have a look at this problem. We're starting to look at our money problems from last week. But yeah, I'm going to stop there, and I'll do the rest of it according to that Friday 2:15 p.m. Have a lovely day.